Welcome to another lesson on differentiation, the four-step rule. And this is exercise 3. Now we have an example. Y is equal to 5x cubed minus 2x. Using the four-step rule, first step, so here we have y plus delta y is equal to 5 times x plus delta x raised to 3 minus 2x plus delta x. Now we are cubing a binomial, and in cubing a binomial, we follow the rule stated on the special products. Okay, but first let us solve for delta y. Now we have to cube a binomial from the special product. We have x cubed plus 3x squared delta x plus 3x delta x squared plus delta x cubed minus 2x minus 2 delta x minus y, and y is equal to 5x cubed minus 2x, and since this is subtracted, it becomes plus 2x. Okay, now we continue. By distribution property of multiplication, we have here 5x cubed plus 15x squared delta x plus 15x delta x squared plus 5 delta x cubed. Now we can cancel right away the negative 2x and the positive 2x. So we are left with minus 2 delta x minus 5x cubed. Now we can readily cancel 5x cubed and the minus 5x cubed. Rewriting delta y, we have 15x squared delta x plus 15x delta x squared plus 5 delta x cubed minus 2 delta x. Now to find delta y over delta x, we divide both sides by delta x. So let us take a ruler. Now we have delta x. Now we have delta y over delta x. We have 15x squared divided by delta x, so we have 15x squared plus, divide this by delta x, we have 15x delta x plus 5 delta x squared for this, and then we have a minus 2. Solving for dy dx, we know that dy dx is equal to the limit of 15x squared plus 15x delta x plus 5 delta x squared minus 2 as delta x approaches 0. Okay? Now, without applying the rule of the limits to shorten the process, no, we will just substitute delta x with 0 and finding the limit for 15x squared. We have, since delta x is 0, we have 15x squared, and we substitute delta x with 0 and this becomes 0. This also becomes 0, and this is the limit of negative 2 as delta x approaches 0, and that is equal to minus 2. So dy dx is equal to 15x squared minus 2. Now we have another example. Example number 2. Y is equal to 2 over 2x over 2x plus 1. Okay? Now solving for the derivative, we have delta y plus y, and then we have 2 times x plus delta x over 2 times x plus delta x plus 1. Now, solving for delta y, we have 2x plus delta x over 2x plus delta x plus 1 minus y, and y is equal to this, 2x over 2x plus 1. So, this is a difference of two rational expressions, and to combine them, we need to find the LCD. So, to combine them, we'll just cross multiply. Multiply this denominator by the numerator of the subtrahend, and this denominator by the numerator of the minuend, and then multiply the two denominators. So we have for delta y 2 times x plus delta x times 2x plus 1 minus 2x times 2 times x plus delta x plus 1, and this is enclosed in a bracket because we have an operation here, over 2 x plus delta x plus 1 times 2x plus 1. Okay, so this is a very lengthy process. Now we have, so 2 x times x times 2x, so we have 2 times so we would rather multiply directly, and so we have 4x squared plus 2x plus 4x delta x plus 2 delta x minus 4x squared. So we are now here minus 4x delta x minus 2x over, what do we have at the denominator? We have 2x plus 2 delta x plus 1 times 2x plus 1. Now we simplify the numerator by canceling terms. So we have 4x squared cancelled. And then we have plus 2x minus 2x. So we are left with 4x delta x, another one. So we have the delta y as 2 delta x over this denominator, 2x plus 2 delta x plus 1 times 2x plus 1. So we make this division line longer. Now, to simplify things, we find for, no, rather, now we solve for dy dx. And dy dx is equal to delta y, or the limit of delta y over delta x as delta x approaches 0. And since we have delta y over delta x, as if we are going to divide both sides of the equation by delta x here, we end up with 2 over 2x plus 2 delta x plus 1 times 2x plus 1. So we are running out of space here. Anyway, we're about to finish. So what do we have? If we are going to substitute delta x with 0, we have dy dx equal to 2 over 2x plus 1 times 2x plus 1, or we write 2 over 2x plus 1 squared. And this is the dy dx of the example.